Welcome to EMI-BRAIN, your one-stop channel for tutorials that make learning simple, sharp, and successful.
Okay, let's look at complex number. Complex number. Okay, in our previous class, we looked extensively on the complex number. I will say the word complex number does not mean that something complex. In fact, this is one of the most simplest topics in mathematics, but it's kind of tricky. Are you there? If you're not careful. Now, there are some mathematical evaluations that are practically impossible in mathematics. Like, for example, now the square root of a negative real number. If I have something like this, square root of minus 4, square root of what? Minus 9, square root of minus 25. By the time you punch your calculator to find the root of these numbers, it is impossible. They will tell mathematical error or undefined, or they will put a symbol like this showing that it is not possible at infinity. But root of a positive real number is possible. What's the root of 4? 2. What's the root of 9? 3. What's the root of 25? Is 5. But the root of minus 4 is not possible. I was also a victim in secondary school. My math teacher told me that root of minus 4 is minus 2. Eh? You have such victims here. What's the root of minus 4? I never encountered a problem in mathematics where you are solving and you go to the problem, but you have a root of a negative number. How do you evaluate this in mathematics? Let's say, for example, now let me ask. Watch. Let's say we are solving a problem. I have x squared plus 4 equals to 0. Find what? Find x. Huh? So what we do here? We move this a bit, and we subtract what? 4 from both sides. Is that not? That will give us what? S squared equals to what? Minus 4. To find the value of s, what do we do? Square root both sides. Is that not? That means square root of what? S squared equals square root of what? Minus 4. Square can go with square root. What is our x? S is what? Root of minus 4. So what do you do here? You put the answer as minus 2. You are wrong. It is not possible to find. We call this word complex root. Complex what? Root. This is where the word complex number comes in. But I will show us how to evaluate this. Are you getting it now? Or I put this on your notes. Complex number are those numbers that are made up of two major parts. No, if you have already written this, don't write again. I will tell you when to. I think we stop at conjugate, Abby. So let me just say I can speed up a little. Complex numbers are those numbers that are made up of two major parts or two parts, which are real parts. The real parts and also what? Imaginary parts. Real parts and what? Imaginary what? Parts. Generally, they are expressed as this. Generally, they are expressed as z equals x plus yi, or z equals a plus what? Bi. They are expressed as this. Z equals x plus yi, or a plus what? Bi. Where z is a complex number. The symbol for complex number is what? Is z. That is symbol. S represents the real part of a complex number. What's that y representing? Imaginary part of a complex number. They have two major parts combined together. We have the real parts and what? Imaginary parts. So we are saying that x is equals to a equals to what? Real. Then we also have what? Y is equals to what? B equals to what? Imaginary. Why do we say B is imaginary? Because B is attached to what? A complex value called what? I. If I'm to remove this I, B remains what? A real number. Are you there? So what made B imaginary, or what made Y imaginary because of what? The value called I. Are you there? For example, if we are given that Z equals to 2 plus 4i, and we also find the real parts of Z and the imaginary part of what? Of Z. What's the real part of Z here? 2. What imaginary part of z, yeah? 4, not 4i. Are you there? Is what? 4. So what made 4 imaginary is what? Is I. Are you getting it now? Now let's look at, in our last class, then we talked about how to evaluate what? I, abi? Or derivation of I. How do we have this I? How did this I come about? I explained what we call derivation of what? Of I. Listen, from this expression, given that s squared plus what? 1 equals to what? 0. And we have to find what? Find x. To solve for x, what do? We have to subtract what? 1 from both sides, right? We say subtract 1 from what? From both what? From both sides. So that means what? S squared plus what? 1 minus 1 abi is equals to what? 0 minus what? 1. That will give us what, yeah? S squared equals to what? Minus 1. We also call this, someone will say move plus 1 to the other side, abi? Anyhow you want to do it. You must not follow this process in mathematics. You can just move it and all that. That will give us this. So how do we solve for this x here? You can tell me. We square root, right? Square root what? Both sides. Please pay attention. That means what? Square root of what? S squared equals square root of what? Minus 1. Can square go with square root? We are left to what? Root of what? Minus 1. Which is what? Somebody? Undefined. If you have a calculator, they can punch for me. What's the root of minus 1? Or the root of negative number? Mass error. Meaning it is not possible. Either it is undefined. It is at infinity. Now, for me to define this, I can't just say it is undefined. I have to define it. To define this, I will say let x equals to what? Somebody, I. We use I to define the value of x. If x equals to I, what will be here? That means that what? I is equals to what? Root of what? Minus 1. Are you following? If x is I, it means that I is what? Minus 1. If my x is actually I, and we are saying that s squared is equals to what? Minus 1. What will be here? I squared. Abi? That means also I squared is equals to what? Minus 1. Take note of these two major things throughout our journey in complex number. I will keep on using this. Anywhere you see I represents what? Root of what? Minus 1. What of I squared? Minus 1. Please take note. So this is how we come about the value of I. Okay? Now, let me give us an instance so that we can learn. One example where we are just like, okay. Look at this. For example, if we are given like s squared plus 16 equals to what? 0. And we have to find what? Find what? X. Are you there? Now, listen. How do we find x? What do we do first? We subtract what? 16 from both sides. That implies what, yeah? S squared equals to what? Minus 16. Do you agree with me? So what the next, yeah? We square root what? We square root what? Both sides, right? And that will give us what? X. Square root of what? S squared equals square root of what? Minus 16. This can go with this. So x becomes what? Root of what? Minus what? 16. Now, because I've already defined the root of a negative number, I can also define this. In mathematics, there's a law of sod that says that sod what? A times sod what? B is equal to what? Sod what? AB. Meaning I can also express this as sod minus 16 can also be what? Sod what? Minus 1 times what? Sod what? 16. Is that not? Because I've already defined this. Also, I can break this into these components. Now I can find the root of 16, right? What's the root of 16? 4. What we say is root of minus 1 is what? I. Is that not I? Are you following? Are you getting it? Okay, from where? From this side here. This one here. Okay. This is the law of sod under multiplication that says sod A times sod B equals to sod what? AB. If I have this, if I say sod 2 times sod 3, that gives us what? Sod 6. Do you understand? Now, we have sod what? Minus 16. Sod minus 16 is same as sod minus 1 times sod what? 16. You know why? Minus 1 times 16 is what? Minus 16. Do you agree with that? Now, what do we define this as? It's I. Abi? Then I times what here? 4. What's the answer for I? So that means that here becomes what? X equals to what? Sod what? Minus 1 times sod what? 16. Which is same as what? I, right? I times what? 4. What's the answer here? 4I. Is that clear, someone? We have just put it down somewhere. Put this down somewhere. Now, you have learned how to evaluate root of a negative number. Even if we have something like this, if I have to evaluate this now, let me ask, if I have a root of minus 4, what will it be? 2I, thank you. Which is same as what? Root minus 1 times what? With what? 4, right? Here we have I times what? 2. What's the answer? 2I. Now you have learned. So, in any aspect of mathematics, in any aspect, whenever you see the root of a negative number, always introduce what to it? Your I. Okay, so let's proceed. Let's proceed. Okay, the next is evaluation of I. Evaluation of what? I. Let's evaluate the following. Evaluate the following. I won't do much of this. 1, we have I squared. Number 2, I cubed. Number 3, I raised power 4. Number 4, I raised power 8. Number 5, I raised power 9. Number 6, I raised power 20. 7, I raised power 21. Or let's say 23. I raised power 41. Let's play around this. Okay? Let's play around this. Now listen, whenever you're evaluating just I, all of this, I'm evaluating what? I components. Now we all know what I represents, Abi. I represents what? Root of what? Minus 1. Is that not? Now, come to evaluate I. Your answer must fall between these 4. Either minus 1 or 1. Or either what? Minus I or what? Or I. Anytime you're evaluating I components, your answer must fall between these 4. For example, the first one we know. We don't believe the evaluation. What is I squared? And what I gave us? What is I squared again? Minus 1, Abi. That's the answer to this. Minus 1. This is your note, Abi. Now let's evaluate I cube. To evaluate I cube, I have to split this into 2 components or into 3. I have to reduce it. But first of all, I have to bring out what from I cube squared. Are you getting it now? I squared times what will give me I cube? I squared times I, law of indices. Is that not? So the first is to bring out what? To bring out what? I squared. Then multiply with what? With I. Law of indices says that if I have A raised power what? B times A raised power C, the law says what? I will pick a common base, Abi, which is A raised power what? B plus what? C. If here is 2 and here is 3, what will be the answer here? 5. Abi? Are you there? So for this now, these two they are common base. So that means that by the time I pick a common base, which is this, when you add up the power, what the power of I here is 1. What's 1 plus 2? 3. Now let's evaluate further. We have already defined I squared as what? Minus 1. Here becomes what? Minus 1 times what? Sorry? Minus 1 times what? Times I. What's the answer? Minus I. Is the answer here? Yes. I said whenever you're evaluating I, your answer must fall between these 4 components. Now let's go. The next is what? I raised power 4. What did I say first? I have to bring out what out? I squared. I squared times what will give us I raised power 4? I squared times I squared. Is that not? So I can say times what? I squared. But because I have other bigger values of power, I can't keep on picking out I squared times I squared times I squared. I will not go far like that. So I can say this can also be expressed. There's a law called power law of indices. I square always power what? Somebody 2. Do you agree with me? The law says that if I have A raised power B, always power what? C. What you have here is A raised power what? BC. For example, A raised power 2 times A raised power 4. What will it be? A raised power what? 2 times 4 is 8. Do you understand the concept here? So what's 2 times 2 here? Is 4. So can we now solve? What's our I squared? Minus 1 all squared equals to what? 1. Minus 1 all squared means what? Minus 1 times what? Minus 1. Are you getting the gist here? Now listen, I told them something in the previous one. I said a negative number raised by what? Even number is equals to what? Huh? Plus, Abi. But the negative number raised by what? Odd number is equals to what? Negative. Do you understand? Now that implies that minus 1 raised by odd is what? Minus 1. Minus 1 raised by even is what? Somebody? Plus 1. Hope you are aware. Minus 1 raised by 5 is same as minus 1 times minus 1 times minus 1. 1 times 1 times 1 times 1 is still 1. It's still 1. So minus 1 raised by odd number is what? Minus 1. But raised by even is what? 1. But look at this now. Minus 1 is raised by what? 2. Is 2 even or odd? So what will it be? 1. Are you getting it now? Good. To avoid bringing out minus 1 times minus 1 times, there's no time for that, okay? Now, how do we solve this? This I raised by 8, right? What do we say we'll bring out first? Our I squared. So I squared 2 times what will give us 8? 4. Good. Are you getting it? 4 is it even or odd? But let's put this first. I squared we agreed is what? Minus 1 all raised by 4. Is 4 even or odd? So minus 1 raised by even is what? What will be the answer? 1. Is that clear? So what's the next here? I raised by 9. What do we say we're going to bring out first? I what? Squared. Now, there is no direct number that I can multiply 2 with that will give us what? 9. But I have a number that I can multiply 2 with that will give us a number close to 9, which is 4. Is that not? 4 times 2 is what? Is 8. So if I should add 8 here, then I have to bring out what? 1i. Exactly. What I'm saying is that here can be what? This power 4 times what? Yeah? Times i. Because 2 times 4 is what? Is 8. So the power of I here is what? Is 8. Plus 1, making it what? 9. Exactly, somebody. Can I proceed? Are you getting it? So let's go. So what do you have here? Minus what? 1. Raised by what? 4 times what? I. Minus 1 raised by even is what? Is 1. So 1 times I is what? Is I. This answer is among the 4 answers? Yeah, it's among the 4 answers. So what's the next one, yeah? I raised by 20. Meaning what, yeah? I squared raised by what? 10. And that will give us minus 1 raised by 10 equals to what? 1. Okay. Now if you solve this for me, let me see your answer. This and this. 23 and 41. Let me see what you get. Okay, so let's look at it. So yeah. So how do you simplify this? We have what here? We have I squared, right? I squared times what? Times 11. Good. 11 times 2 is what? 22. So times what? 5. And that will give us what? Minus 1 always by what? 11 times I. This will give us minus I, right? Because minus 1 is by 11 is minus 1. Then times I is what? Minus I. Good. What of 41? I squared always by what? 20 times what? I. That will give us minus 1 raised by 20 times I. So answer is what? Is I. Right? Minus 1 raised by 20 is 1. 1 times I is what? Is I. That's good. Okay, then let's look at the applications. The basic operations rather. Connect me? I think we have entered. Let me see how I can fasten up this because I won't come back to this aspect again. Those will be coming from next week. We'll go back to the YouTube channel and watch. I think it's better that way than forward ever. Okay, basic operation. Basic operation. Operations in what? In complex what? Number. Complex number. Okay? Well, look at, we have some basic operation. We have what called the addition and what? And subtraction. Number 2, we have the multiplication. Multiplication. This is in 2 forms. We have the what? The by single factor. Single what? Factor. And this is by what? 2 or more what? Complex what? Complex number. Complex number. Number 3, division, right? Okay. Okay, conjugate, I guess. Conjugate of complex number. Number 4, we talked about what? Division, right? Division of complex number. Number 5, we talked about modulus, rationalization. Okay, this is also, from here, you can talk about rationalization under division. Before you can divide, you have to rationalize the denominator. Number 5 is modulus. Modulus, also called the length of a complex number. Okay, then we have what we call forms, right? Forms of complex number. There are various forms we'll look at throughout this journey. There are forms of complex number. We have what we call the general form. Number 2, we have what we call the exponential form. Exponential form. Number 3, we have the cis form. The cis, C-I-X, cis form. The triangular form is z equals to the general one we know, x plus yi. Exponential form is z equals to r exponential I theta. Okay, where theta is in radian. Is in what? In radian. The cis form is z equals to r cis theta. Then the fourth one, which is the last aspect of this topic, is called the nth root form, which is z raised by what? N equals r raised by what? 1 over n. We have cos. No, not the last one. I didn't show us the polar form, right? Thank you. The polar form, which is z equals to r cos theta plus I sine theta, where theta is also in radian. Please take note. Number 5 is called the nth root form, which is z raised by n equals to r raised by 1 over n. We have cos theta. This space might not be enough. Z raised by n equals r raised by 1 over n. We have cos theta over n plus 2 pi k over n plus I sine theta over n plus 2 pi k over n. This is called the nth root form. So all of these are what we're discussing about in complex number. Okay, can I go? Can I? Okay, so what the first one there? Addition and what? And subtraction. Addition and what? Subtraction. Addition and subtraction. Okay, we have put this down, right? Right. Addition. The addition and subtraction, right? The addition and subtraction of two or more complex number will always result to the formation of a new complex number. The addition and subtraction of two or more complex number will always result to the formation. Of a new complex number. Will always result to the formation of a new complex number. For example, if we are given that z1 equals to a plus bi and z2 equals to c plus di, and we also find number 1 z1 plus what? Z2. Number 2, find z1 minus what? Z2. Now, why adding? I will add the real to the real. Also add what? Imaginary to what? Imaginary. So solution to this is very simple. So if I'm to add my z1 plus z2, what's that z1? A plus what? Bi, right? Plus, what's that z2? C plus DI. So let's add up. A plus C give us what? A plus C, right? Okay. Plus, what do you have there? DI plus DI. It's like saying B plus D all multiply with what? I. Do you agree with me? Because both of them have I. So when you add up, you can bring out the I out. So this is the answer to this. So likewise, for that of subtraction, what will it be? A minus C, right? Sorry, A plus C rather. What am I saying? A minus C. I'm subtracting this, right? A minus C. A minus C. Then plus. What will be here? B minus what? B minus D. Or what? I. Okay, let me give us a real value to this so that we can see how it goes. Example 2, for instance. If we are given Z1 equals 2 plus 8i and Z2 equals 8 minus or plus, let me start with this, plus 2i. And we also find number 1, Z1 plus what? Z2. Number 2, Z1 minus what? Z2. We have to add then number 3, find the real part of Z1. Find the real part of Z1 plus what? Z2. Number 4. Number 5, find the imaginary part of Z1 plus what? Z2. Are you there? Put this down so we can solve. So solution. The first one says what? Z1 plus what? Z2. What's that Z1 there? 2 plus what? 8i, right? What is Z2? 8 plus what? 2i. So what we do here, we add the rate of the right? What's 8 plus 2 there? 10. What's 8i plus 2i? Still 10 what? I. Not 10i squared. Is what? 10i. I can only use I squared for multiplying I with what? With I, right? Okay, so that is just for that. So this is my Z1 plus what? Z2. Number 2 is what? Z1 minus what? Z2. What's that Z1 here? The same thing, 2 plus what? 8i plus, minus 8 plus what? 2i. So let's go. What is 2 minus 8? What is 2 minus 8? Minus 6, right? 8i minus 2i is what? Plus what? 6i. So this is my Z1 minus what? Z2. Number 3 is what? They say the real part of what? Z1. This is very simple. What is the real part of Z1? So number 3, number what? Number 4. The real part of what? Z1 plus what? Z2. What's the real part of this? 10. From here, right? 10. What's the next one? The imaginary part of Z1 plus what? Z2 is what? 10 also. What is the real part of this? Minus 6. What's the imaginary part? 6. No, 6. So bring up the imaginary value, don't include the I. Just the 6. Or for this is what? 10. Exactly. Yes. Where? Let's check. 2 minus 8 minus 6. So 8 minus 2 is plus. Do you understand? Okay. Now let's move down to number 2 application. Just remind me, I'll give us class maybe assignments after we are done. Number 2 is what there, multiplication, right? And we saw they are in how many forms? 2 forms, right? Okay. Number 2, multiplication. If we are given Z1 equals to 2 plus 3i and Z2 equals to 3 minus 4i, and we also find the following. Find number 1, 2z1, number 2, 3z2, number 3, z1, z2, number 4, 4z1, z2, number 5. Okay, let's stop here so I will not stress ourselves much. Look at it, very simple. Z1 is 2 plus 3i. What is Z2? 3 minus 4i. We have to find 2z1. Are you there? This is by a single factor. What's the factor here? Factor 2. Meaning 2 is multiplying z1. Are you there? Okay, so solution to this is that to find our 2z1 as 2 times. What's that z1 here? 2 plus what? 3i. So here I have to just expand, right? 2 times 2 is what? 4. 2 times 3i is what? 6i. So we have 4 plus what? 6i. Exactly. Exactly. Number 2 is what? 3z2. Meaning 3 times z2. So we have 3. What's that z2 here? 3 minus what? 4i. So if I'm to expand this, 3 times 3 will give us what? 9, right? 3 times minus 4i is what? Minus what? 12i. Is that not? What is the imaginary part of this? Minus 12. Minus what? 12. Minus sign is attached to 12. Okay, so the next is what? The third one is what? Z1, Z2. This simply means Z1 dot or Z1 times. I'm multiplying Z1 with what? With Z2. That will give us what, yeah? What's that Z1? 2 plus what? 3i. Multiply, right? With what? 3 minus what? 4i. Is that clear? Okay, so let's go. Now, why multiplying two complex number together? You should know the process, right? Multiply these 2 by 3. Multiply these 2 by what? Minus 4. Multiply 3i with what? 3. 3i with what? Minus 4i. Can we proceed? What is 2 times 3? 6. What is 2 times minus 4i? Minus 8i. What is 3i times 3? Plus what? 9i. What is 3i times minus 4i? Is minus what? 12i squared. This is where I squared comes in. You know why we have I squared here? Because I times I is what? Minus I squared. 3 times minus 4 is minus 12. So I times I is what? I squared. Exactly. Okay. These two are then like terms. Are then like terms. Can they be added together? So minus 8 plus 9. 9i is what? Minus 8i plus 9i. No? X plus I. Minus 8 is less than 9. So the answer will be what? Positive. Exactly. So that will give us what? 6 plus what? I. Minus 12 times what? Minus 1. Do you agree with me? No, so the value of I squared represents what? Minus 1. Exactly. Okay. So let's finish up this. So this will give us what? Yeah? 6 plus I. Minus 12 times minus 1 is what? Plus what? 12. Minus 12 now is multiplying what? The minus 1 in brackets. So this and this are products. So minus times minus is what? Is plus. So we have plus 12. Exactly. Are you getting it? Okay. So do you have like terms here again? 6 and 12 are like terms, are we? Can we add them together? So what do you have? 6 plus 12 is what? That is 18, right? Good. Where is that just now? So here we have Z1, Z2 becomes what? 18 plus what? Plus I. Exactly. What is the real part of this? Yeah? 18. What's the imaginary part? What's the imaginary part? It's 1 now. This is 1 I, Abi. So it's 1. It's 1. Okay, put this down. Okay, let me leave this, right? Now what is there? Number 4 says what? 4 Z1 Z2. Meaning 4 times what? 18 plus what? I. Are you there? What is 4 times 18? Oh, yeah, punch your calculator. I hope you have bought calculator, right? Scientific. So you can start practicing with it. Yeah? 72. So we have 72 plus what? What's 4 times I? 4I. Okay. Put it down. Let's look at one more example under multiplication. Have you heard about Pascal triangle in mathematics? Binomial expansion. Hmm? Sometimes they might give you something like this. 2 plus 4i raised power 5 to expand. Or raised power what? Raised power 7 to expand. You know if you are doing raised power 2, it's very easy to expand. What do you do here? 2 plus 4i, abi? Times what? 2 plus 4i. But if you are doing like 7, that's where you can't start doing that this in 7 places. You will not finish that work that day. So I'll show us how to expand, okay? Either using binomial expansion formula or Pascal what? Triangle. Are you done with this? Can I go? Okay, let's evaluate this. Evaluate. Let me use simple value. 2 plus 3r always power 5. Let me show us something under binomial expansion. There's a number called Pascal. Yeah? We discovered a triangle called Pascal what? Triangle. Using expansion. Using binomial what? Expansion. In Pascal, according to Pascal, so the Pascal started by showing us that. Let me show you something. If I have a plus b, these are how many terms here? 2 terms, B. This is of this kind, is it not? Our a here is what? 2. What's that b here? 3i. Are you there? So according to if I have a plus b raised power 0, what's the expansion here? Is 1. Do you know why it's 1? And raised power 0 is what? Is 1. Are you getting it now? That means the coefficient of a plus b raised power 0 is what? Is 1. That's coefficient. Are you getting it? But if I have this a plus b all raised power 2, coefficient of a plus b raised power 2 is what? Huh? Okay, let me say raised power 1, sorry. Raised power 1. What's the coefficient here? A plus b raised power 1 is same as a plus b. Are you aware? So the power is just 1. What's the coefficient of a here? 1. What of b? 1. So here becomes what? Somebody? 1, 1. According to Pascal. Pascal uses the coefficient of these values here for expansion. The first one is what? A plus b raised power 0, which is 1. What is the second one? A plus b raised power 1, which is what? 1, 1. The third will now be what? A plus b raised power what now? 2. How do you get the coefficient of this? Let me show you something. A plus b all raised power 2, we all know is what? A plus b times what? A plus b, right? What is a times a here? A square. What's a times b? ab. What is b times a? Is ab, right? What is b times b? Is what? B square. These two are then like terms, yes. And can they be added? That means our a square plus what? ab plus ab is what? Is 2ab. Plus what? Somebody? B square. So what's the coefficient here? Here's 1 ab for a square. What about ab? Is 2. What about this? 1. So that means the value for this becomes what? 1, 2, 1. But the concept here is this. If you don't want to go through this process of expansion, once you have indicated 1 for this, and this is what? 1, 1. Then I can generate the remaining one without expansion. How do we do that? Let me show you. So we have 1 abi. We have what here? 1, 1. The next is that I have to put 1 here. And add up 1 plus 1 is what? Is 2. Then I'll put what here again? 1. For a plus b, always power what? 3. The same concept. I'll put what here? 1. What is 1 plus 2? 3. What is 2 plus 1? 3. I'll put what here again? 1. For a plus b, raised power what? 4. The same thing we also apply. I'll put what here? 1. What's 1 plus 3? 4. What's 3 plus 3? 6. What is 3 plus 1? 4. And what again? 1. Even if I have a plus b always power what? 5, which is what I want to solve, abi? Are you following somebody? What we do here? We have 1. 1 plus 4 is what? 5. 4 plus 6 is what? 10. 10. What again? 5. 1. I can continue this way. Even to 7 to 8 to 9. Are you getting it? There's a topic in mathematics. I will take this as a single topic. I'm just showing you how we can be able to expand this. Okay? But let me take us through a journey before I come to this. Let me take us through a journey. Look at this. No, stop writing. I will give you time. You write. Look at this. If I have a plus b all squared, If I don't want to bring out this in two places, I can adopt the concept of what? Pascal what? Triangle. The first thing I will need to do is I will take, what is the power here? 2. That means a plus b raised to power 2. We have 3 times. We have what? 3 times. Just add 1 to 2, making it what? 3. So it means I have to bring out the product of a and b in 3 places as what? AB plus what? AB plus what? AB. That's the first thing. If I have 3 here, to be how many times? 4. So let's work with this first, Abi. Are you there? Then the power of A will be decreasing from 2 to what? To 0. While the power of B will be what? Increasing from 0 to what? To 2. Based on this power. So what will be here for A? 2, 1 and what? 0. What will be here for B? 0, 1 and what? And 2. Are you there? In the binomial expansion, what we say is the coefficient of A plus B raised to power 2. 1, 2 what? 1. So I have to import. I'll put what here? 1. I'll put what here? 2. And put what here? 1. We know 1 times anything is still that thing, Abi. What is B raised to power 0 is 1. Times A squared times 1 is what? Is what? A squared. You agree, Abi? Plus what? A raised to power 1 is what? Is A. B raised to power 1 is what? Is B. So that means 2 times AB is what? Is 2AB. Plus A raised to power 0 is what? 1. Times 1 times B squared is what? B squared. Are you seeing it now? How we got this? Or if you want to start saying A plus B in how many places? 2 places. That's another long process, because you can't do this when the power is what? Is high. That's like power 5 or power 6. If you do that, in fact, before you solve that question, it's already like 30 minutes. Let's go. The next one is what? A plus B raised by 3. Abi? Let me show you something. How many times will I bring out here? How many product of AB? 4. AB plus what? AB plus what? AB plus what? AB. What will be the power of A here? From 3 downward. Abi? From 3, we have 3, 2, 1, 0. What will the power of B here? 0, 1, 2, 3. What the coefficient of A plus B raised to power 3? From that place. What the coefficient of 1, 3, 3, 1. So 1, Abi? 3, 3 what? 1. Are you getting the gist here? So what do you have here? What B raised to power 0? 1 times A cube times 1 is what? A cube. Abi? Plus, here we have 3A squared B. Right? B raised to power 1 is still B. Is that not? Plus what? 3AB squared. Then plus what? This is B cube, right? B cube times A raised to power 0 times 1 is what? Is B cube. Hope you are aware. That's expansion for this. Let's play around. A plus B raised to power 5. Raised to power what? 5. How many times will I bring out AB? 6. So let's go. AB plus what? AB plus what? AB plus what? AB plus what? AB. 1, 2, 3, 4, 5 plus AB. The power of A will be what here? 5 to decrease. 5, 4, 3, 2, 1, 0. What about here? 0, 1, 2, 3, 4, and what? And 5. Are you getting it this here? So let's import the coefficients. A plus B raised to power 5 is what? 1, 5, right? What again is there? 10. What again? 10. What again? 5 and what? 1. What's the final answer here? This is A raised to power 5, right? Plus what? 5A raised to power 4B plus what? Plus 10 what? A cube B squared plus what? 10 A squared B what? Cube plus what? 5A B raised to power 4 plus B raised to power 5. The answer for this is that. Exactly. We have put this down. You know, I've not solved this, right? I'm just showing us how to expand. You have to learn this because in your biology, there's a course called genetics in biology. You will need this concept. They will tell you in a family of 20, what the probability of having a boy or a girl. You have to use binomial expansion. That simply means that A plus B raised to power 20. You keep on expanding. That will not give you the probability. But I won't go into that now. When we enter biology, I will show you how to solve it. Binomial expansion. We call that probability in genetics. So learn this expansion now, so that you won't say I've not explained. So let's look at this question now. Are you there? So to solve this, what do we do? Let's look at this. I have to say recall that A plus B, right? Always power 5. Or I will just say let what? A equals to what? Yeah? 2. And let B equals to what? 3i. Let A equals to this. B equals to what? This. Therefore, that means that, or then recall that A plus B raised by 5. What do you say is the expansion we have here? No, this expansion is same with this expression here. So what do you have here? A raised by 5 plus what? 5 A raised by 4 B plus what? 10 A raised by what? 3 B square, right? Plus what? 10 A raised by what? 2 B cube plus what? 5A B raised by 4 plus B raised by 5. Now, since we say A is 2, B is what? 3i. That means that anywhere we see A, we put what? 2. Then B, we put what? Okay, now let's go. Therefore, what will be here is 2 plus what? 3i, right? Raised by 5 equals, what's that A? 2 raised by 5 plus what? 5 times 2 raised by 4. 3i raised by what? Nothing, right? Good. Plus 10. What's that A? 2 raised by what? 3. B is what again? 3i raised by 2. Plus what? 10. 2 raised by what? 2. 3i raised by what? 3. Plus what? 5. A is what? 2. 3i raised by what? 4. Once again? Plus 3i raised by 5. 2 raised by 5 is what? I guess it's 32. Right? 2 times 2 times 2 times 2 times 2. So we have 2 plus 3i raised by 5. That will give us what here? Okay. Plus, what do you have here? What's 2 raised by 4? What is 2 raised by 4? 16. 16 times 5 is what? Take from me. Let me fast. 80, right? Are you sure it's 80? Then that same 80 times 3, what do you have? Is it? 2, 2, 4, 240 what? I. Hope you understand what happened here. 2 raised by 4 is 16. 16 times 5. Then multiply by what? 3. That gives us what? 240i, right? Is that clear? Can we proceed to this? What is 2 raised by 3? 8. 8 times 2 is what? So 8 times 10 is what? Sorry. 80. 2 raised by 2 is what, yeah? 2 raised by 2 is what? Sorry, 3 raised by 2 is what, yeah? This is 9i squared. If I have this, 3i all squared, that will give us what? 9i squared. Hope you are aware. Are you aware? 3i raised by 2 is 9i squared, meaning 3i times what? 3i, right? That gives us what? 9i squared. So let's come again. 2 raised by 3 is what? 8. 8 times 10 is what? 80. 80 times 9i squared is what? Take from me. What's 80 times 9? 720 what? I squared, right? Good. Plus, we are done with this. Let's come to this now. What's 2 raised by 4? So 2 raised by 2, 4. I gave the answer already. 2 raised by 2 is what? 4. 4 times 10 is what? 40. 3 raised by 3 is what? 27, right? 3 raised by 3 is 3 times 3 times what? 3. 3 times 3 is 9. What 9 times 3? Is 7. So 27i cube, right? Is that not? So let's go. 27 times 4 times 10 is what? 10880. Are you sure? 80 I is power what? I cube. Are you sure of this? Okay. So let's go. Let's move down to this part. Plus, what is 2 times 5 here? 10. 3 raised power 4 is what? 81. Good. That is 81 I raised power 4, right? So let's go. 81 times 2 times 5. 8, 10. Are you sure? I raised power what? 4, right? Let's go. Plus, what is 3 I raised power 5? What 3 raised power 5? 3 raised power 5. Huh? 2, 4, 3, I raised power 5. Are you sure? Hmm? Hope you know how you got this. 3 I raised power 5. Okay. Now let's evaluate further. We have to evaluate this. If you're evaluating this, your answer, your answer must be in what form? In the form of what? A plus what? Bi. Or S plus what? Yi, right? Now already we have I here, so I can't evaluate this further. It means I can only evaluate what? This, and this. Are you following? But don't forget that we have already evaluated I before. Then anyway we see I square. What's I square? Minus 1. Now let's import and see. Here we have 32 plus what? 240 what? I plus 720 times what? Minus 1, right? Plus 1080. What is I cube? Let's go back to I cube. What's I cube? It's I squared times I, right? I remember that. Which is what? Minus 1 times what? I. And what do you have here? Minus I. So what will be here? Minus I. Okay. So let's evaluate this. Plus 8 10. What is I raised power 4? Good. So let's check again. I squared all raised power 2, right? Which is what? Minus 1. All squared is what? 1. So no need of putting 1. But let's just put times 1. So plus what? So what do you have here? 2, 4, 3. Let's evaluate I raised power 5. I raised power 5 is what? I squared all raised power 4 times what? I. So minus 1 raised power 4 times I will give us what? 1 times I equals to what? I. So what will be here? Times I. So what we have here to be what? 32 plus what? 240I plus minus, right? Minus 720. Okay? Minus 1080I. Are you following? 1080 times minus I is what? Minus 1080I, right? Good. What about this? Plus what? 8 10. Is that not? Okay. Plus what? 243 what? I. Now, are there like terms here? What are like terms? 240I minus 1080I plus 243I. So what do you have there? Okay, let's add up the real numbers first. What are the real numbers here? 32 minus 720. What do you have? Then plus 810. 122. 122. Okay. Then let's add up the imaginary. 240I minus 1080I plus 243I minus 597I. Final what? Answer. Now the next one we'll look at now is what? Conjugate, right? Conjugate. Then from conjugate we go into rationalization, division. So we stop at division. Where? Conjugate. Okay, conjugate. Okay, we're about to enter division. Okay, let's look at conjugate of complex number. Conjugate of complex number. Those who are already here, we have already learned conjugate, right? But let me just repeat. Oh yeah, please write down. Conjugate of a complex number is simply the reverse sign. Conjugate of a complex number is simply the reverse sign of the imaginary part of a complex number. Conjugate of a complex number is simply the reverse sign of the imaginary part. The reverse sign of the imaginary parts of a complex number. Meaning conjugate only affects imaginary side. Are you there? For example, oh yeah, right, put this down. The conjugate of Z equals A plus BI is what? Z bar equals what? A minus what? Minus BI. The symbol for conjugate is simply this. Or what? Or this. Asterisk. Z bar represents what? Conjugates of a complex number. Bar. Bar. B-A-R. Right there? Or Z asterisk. But for IMSU textbook, we use what? Z bar. But for other material, you can be saying Z asterisk. They all mean the same thing. They all mean what? conjugates. Either the same. Okay. So conjugate simply means the reverse. What do you notice here? What the reverse sign of this imaginary part here? Minus. That means that the conjugate of a plus bi is what? A minus bi. Also, the conjugate of a minus bi is what? A plus bi. Are you getting the gist here? Okay, let's look at some questions. Find the conjugate of the following. Find the conjugates. This is very simple, okay? Of the following. Number 1, Z1 equals 2 plus 3i. Number 2, Z2 equals minus 3 plus 4 minus 3 minus 4i. Let me just say 3 minus 4i. Number 3, Z3 equals minus 3 plus 6i. Z4 equals 20i. Z5 equals minus 6i. Alright. Number 6, Z6 equals 5. Number 7, Z7 equals minus 10. Alright. Okay. Let's look at this. Solution to this is very simple. For the first one, Z1 conjugate, Abi, is simply what? What's the answer there? 2 minus what? 3r. Number 2, what is Z2 conjugate? 3 plus what? 4r. Number 3, what is Z3 conjugate? Minus 3 minus what? 6i. Are you seeing it now? It does not affect imaginary, sorry, the real part, only what? Imaginary part. Number 4, what is Z4 conjugate? Minus what? 20i. Number 5, what is Z5 conjugate? 6i. Number 6, what is Z6 conjugate? What will that be? 5. Why is it 5? Conjugate only affects imaginary. 5 is it real or imaginary? Real. So that means the conjugate of 5 is still 5. Here I got the sign that changes of the imaginary part. So for this now, this is just a real number. So it will remain that. What about this? The same thing, right? Z7 conjugate is what? Minus 10. Do you understand the concept here? Then I give a note. I say note that the product, right? The product of two conjugates. Conjugates complex number. Complex what? Number. We always, we what? We always result to what? To the formation of a what? Of a real number. The product of two conjugates complex number will always result to the formation of a real number. Of a real what? Number. Meaning, if I should multiply Z1 with Z1 what? Conjugates, I will have what? A real number. If I should multiply Z2 with what? Z2 what? Conjugate, I will have what? A real number. Let's analyze. Let's see. Can I clean this page? Okay. Now what I mean here is that Z1 dot what? Z1 what? Conjugates should give us what? What is Z1? 2 plus what? 3i. What is Z1 conjugates? 2 minus what? 3i. Let's look at this test. 2 times 2 will give us what? 4, right? What is 2 times minus 3i? Minus what? 6i. 3i times 2 is what? Plus what? 6i. Are you following? 3i times minus 3i is what? Minus what? 9i squared. 9 what? I squared. So this will give us 4. Minus 6i plus 6i. We cancel out. It's like saying 6i minus what? 6i. If we have similar number but with opposite sign, what happens? They will just cancel out. So minus 6i plus 6i is 0, right? Okay. So 4 minus 9 times, what was the I squared? minus 1. Minus 9 times minus 1 is what? You have 4 plus what? 9. Is that not? Huh? Okay, so what do you have here? 13. Is 13 real or imaginary? Real. So when you multiply any of the conjugates with its complex number, you must have what? A real number. Huh? Very important. Now let's move down to where now? Okay, division of a complex number. Oh yeah, put this and write. To divide two or more complex number, or to divide complex number with another complex number. To divide a complex number with another complex number. Are you there? We multiply the conjugate of the complex number in the denominator. We multiply the complex number, so the conjugate of the complex number, we multiply the conjugates of the complex number in the denominator, either by the numerator, and the denominator itself. By the numerator and the denominator itself. Either. Okay, a good example is this. Example 1. If we are given, for instance, that z1 equals to 2 plus 3i and z2 equals 1 plus 2i, and we also find number 1, z1 over what? Z2. Number 2, z2 over what? Z1. Alright, let me add this. Number 3, the real parts of z1 over what? Z2. Solution to this. We also find z1 over what? Z2. What's that z1 given? 2 plus what? 3i, right? Huh? Divided by what? What's that z2? 1 plus what? 2i. Either. In the notes I gave you, what let's say we have to do to divide? We multiply the conjugate of what? In the denominator, right? Which of this is in the denominator? 1 plus 2i. What the conjugate of 1 plus 2i? 1 minus 2i. Exactly. So that means I'm going to multiply this with what? 1 minus what? 2i. Over what? 1 minus what? 2i. It simply means that I'm multiplying both the numerator and what? Denominator itself with the conjugate. I'm multiplying this with this, Abi. Then this with what? With this. Now can we expand? Don't forget that at this side here, what notice here? I'm multiplying the conjugate, Abi. The conjugate and also I'm multiplying what? The complex number itself. So when you multiply these two, what do you have? A real number. Don't forget. When you multiply complex number with its conjugate, you always have what? A real what? Number. So let's watch what will happen here. What is 2 times 1? It's 2, right? What is 2 times minus 2i? Minus what? 4i. 3i times 1 is what? Huh? 3i. 3i times minus 2 is what? Minus what? 6i squared. Are you there? All divided by what? What is 1 times 1? 1. What is 1 times minus 2i? Minus 2i. 2i times 1 is what? Plus 2i. 2i times minus 2 is what? Minus 4i squared. If you look at this, minus 2 we cancel what? Plus 2. So we are left with what? A real number. Good. So these two are there like 10. Can we add them up? What do you have there when you add up? 2 minus 4i plus 3i is what? Minus I, right? Okay. So minus 6 times, what is I squared? Minus 1. All divided by what? So by the time we go with this will cancel this, right? We are left with what? 1. Minus 4 times what? Minus 1. Do you agree with me? So can we evaluate further? So what do you have here? 2 minus I, right? Minus 6 times minus 1 is what? Plus 6. Divided by what? Minus 4 times minus 1 is what? So 1 plus what? 4. So what do we have here? These two are dead like terms. So can we add them up? 2 plus 6 is what? 8 minus I divided by what? Somebody? By 5. Final answer. Or you can also express your answer this way. Z1 over what? Z2. Can also be what? 8 over 5, right? Minus what? I over what? 5. Do you get it, this? 8 over 5 minus I over 5. If you take the LCM, you will fall back to this. Are you getting it, this? Okay. So to solve for Z2 over Z1, our Z2 is what? 1 plus 2I over what? 2 plus what? 3I. So what I'm going to do here? Multiply by the conjugate of what? 2 plus 3I, which is 2 minus what? 3I over what? Minus 3I. 1 times 2 is 2. 1 times minus 3I is what? Minus 3I. Okay, so let's go. 2I times 2 is what? 4I, right? 2I times minus 3I is what? Minus 6 what? I squared. All divided by what? 2 times 2 is 4, right? 2 times minus 3I is what? Minus 6I. 3I times 2 is what? Plus 6I, right? So 3I times minus 3I is minus 9I squared. These two will disappear, right? So let's watch. These two are like terms? Yes. So we have 2 minus 3I plus 4 will give us what? Plus I, right? Minus 6 times what? Minus 1. All divided by. Hope you know how we got this. So here we have 4 minus 9 times what? Minus 1. So this will give us 2 plus I plus 6, right? Divided by what? 4 plus what? 9. So 2 plus 6 is what? 8 plus I over what? 13. Which is also same as what? 8 over 13 plus what? I over what? 13. So you are correct. That means you guys understand this. So let's go into modulus. Modulus of a complex number. Like me? Okay. Okay, so the next is modulus of a complex number, right? Yeah, put it down. Modulus of a complex number refers to the length of a complex number. This refers to what? The length. To the length of a complex what? Complex number. This can also be called size. Size of what? Size, magnitude, magnitude, or resultants, of what? A complex what? Number. The same word, different word, but the same meaning. It means modulus, it means length, it means size, it means magnitude. It also means what? Resultants. So if we are given, for instance, now that z equals to what? X plus what? X plus yi. Modulus of z simply means absolute value. Yes, it also means what? Absolute what? Value. This also means absolute value. This absolute value of z, and that will give us what? Square root of what? Of x squared plus what? Plus y squared. Right there? After this, we're going to go into Argand diagram. The concept of this modulus actually came from a diagram called Argand diagram. Okay, complex number can be represented in the diagram called the Argand. Let me show you something. But don't write this. I will still come back to this. Don't put this. If we are saying that complex number is z equals to what? X plus what? Yi, right? That implies that in our Cartesian diagram, here we call it what? Y what? As right, we call your what? X-axis. This is what? Negative y, right? This is what? Negative x. Is that not? Is that not? So it means that the x component from here, x component represents what? The real axis. It's called what? Real what? Axis. Why the y represents what? Imaginary what? Axis. Are you following it down with the diagram? So if my z is equals to what? S plus yi. In this expression here, what do you notice that the value of x is what? Positive, Abi? Y is what? Positive. That means the value of this z falls in the first quadrant. So we have positive y, positive what? X. The value of z can fall here, can fall here, can fall here. But I'm looking at a case where z falls in where? In the first quadrant. Where we have z equals what? Positive s and what? Positive what? Y. That means my z is somewhere here of this form. Here we have y, right? Here is what? X. What do you say we call it again? From here to here is called what? Radius. If you have a circle, what do you know what is a circle? Circle means what? Locus of the point, right? In equal distance from the fixed point called the center. If I have a center here, from here to here is what? Is your radius, right? This is also what? Your radius. So that means I can generate a radius from here, just like this now. If I have a center here, let's assume this is a circle. That means from here to here is what? Our radius. Every point in this circle are called what? They are called the locus. They are called what? Locus. A locus is a point where an object can be found in a what? In a circle. So for this, I have my locus point here. Are you there? But I'm not importing circle because circle is a topic on its own, which is the second semester. Now look at this now. If here is R, here is what? Y. What is here? What is here? X. The value of R here is equals to what? Z what? Modulus. Your R is equals to what? Z modulus. Who can tell me? If I'm to find the value of R, what will I use here? I will use your Pythagoras what? Theorem. Are you aware? My Pythagoras theorem. What do you have? The theorem says what? The square of what? The hypotenuse, right? Equals what? The square of what? Adjacent plus the square of what? Opposite. If the angle is here, if I have an angle theta, where's my opposite? This, right? Y. Where's my hypotenuse? The longest side. Where's my adjacent? X. Any side facing the angle is called what? The opposite. The longest side is called what? Hypotenuse. Then the other side is called what? Adjacent. So that means that here is what? Opposite. Here is what? Here is what? So by this theorem, we are saying that R square is equals to what? Someone help me? S square plus what? Y what? Y square. That means that for me to solve for my R, what do we do? What do we do? I will square root 1 both sides, right? That means my square root of what? R square equals square root of what? S square plus what? Y square. Can square go with square root? What do you have here? R equals to what? With what? S square plus what? Y square. Finally, what do we say R represents? Help me somebody. Z modulus. So here becomes what? Z modulus equals to what? Square root of what? S square plus what? Y square. Are you getting the gist here? So this is how we come about this. This is called modulus of what? Of the complex number. Okay. Just put this down alone. Come. Look at this example. Example 1. Given Z equals 3 plus 4i, then we have to find Z modulus. We are given this. This is very simple. Are you there? So what do we do here? Solution. We are given that our Z equals to what? 3 plus what? 4i. Recall that Z modulus, what do you say the formula we have here? Is S square plus what? Y square. Here our S is what? 3. Our Y is what? 4, not 4i. Are you getting the gist here? From the general expression, Z equals to X plus what? Yi. When you compare, S is 3, right? Y is what? 4, not 4i. Please take notes. So what do you have here? Z modulus, right? Becomes what? Square root of what? 3 square plus what? 4 square. And that will give us what, yeah? Root of what? 9 plus what? 16. That should be root of what? 25. And what do you have there? 5. So that means our Z modulus is simply what? 5. Is that simple? Example 2. If we are given Z equals minus 3 minus 5i, find Z modulus. Solution to this is simply what? I want to say recall that Z modulus equals to what? Square root of what? S squared plus what? Y squared. Here our S is what? Minus 3, right? What's our Y here? Minus 5. Therefore, our Z modulus then becomes what? Square root of what? Yeah? Minus 3 all what? Squared. Plus, what's our Y? Minus 5 all squared. So this will give us what? Yeah? What's root of what square of what? Minus 3? 9. Hope your Y is 9. Okay, plus 25. Are you there? So that will give us what? 30 what? Root of what? 34. Can 34 be reduced to a basic form? You know, in SOD, we have what we call basic form of SOD and the complex form of SOD. Let's check something. Let's check. Let me show you something. If we have 34, what can we 34 is 2, right? 2 years what? Divide 34 by 2, what do you have? 17. Are you sure? Okay, what can go in 17 again? I guess it's 17, right? Okay. Since we have this, that means we cannot reduce this way. Because 2 only appears what? Once. What about 17? Only appears what? Once. So I'll just put my root. So root 2 times 17 is what? Root what? 34. Let me give you another example to explain what I mean by this. If I have root 50, how do we reduce this? What can go in 50? 2. 2 years what? 25. What can go again? 5. 5 years what? 5. What can go here? 5 years what? 1. 5 appears how many times? Take them as 1. What about 2? Put your square root on it. So with 2 times 5 is what? Is 5 root 2. Exactly. Remove that of root 8, the same thing. What's root 8? Let's go. 2 can go, right? What do you have here? 4, thank you. 2 years what? 2. 2 years what? 2 appears how many times? You take these 2 as 1, then put your root here. That'll give us what? 2 root 2. Exactly. Just like that. Yes, solving sort. Another method of solving sort. Even if I want to solve 16, we know the answer is what? 4, Abi? Let's check. 16. What can go in 16? 2. Years what? 4, right? Sorry. 8 rather. 2 years what? 4. 2 years what? 2. 2 years what? 1. 2 appears how many times there? So this and this. Always take 2 of those numbers as 1. So 2 times 2 is what? So the root of 16 is what? Is 4. Instead of cracking your brain, you can just bring it down this way. So for this, the reason why I have to remember, because when you look at this now, if I use 2 here, I still have what? 7. I have 17. What can divide 17 is still 17. So this one appears what? 1, 1. So the only option is just to put what? Roots and roots. So that will give us root 2 times what? Root 17 is same as what? That means I cannot reduce this to basic form of sort. Do you get? Yeah, please take notes.